Welcome, everyone. Today we are exploring a critical component of Azure governance, configuring resource locks. Let's get started. Let's begin by defining what Azure resource locks are. In any cloud environment, it is absolutely critical to prevent the accidental modification or deletion of your resources. Azure resource locks are a built-in security feature designed specifically for this purpose. Unlike role-based access control, which dictates who has permission to perform an action, a resource lock applies a strict restriction across all users and roles. This means that even if a user possesses the highest level of privilege, such as the owner role, the resource lock will still override their permissions and prevent destructive actions. It is a powerful post-deployment security practice. Looking at this diagram, you can clearly see the fundamental flow of how a resource lock operates. On the left, we have a highly privileged administrator attempting to delete an Azure resource. In a standard scenario, their RBC permissions would allow this. However, the resource lock intercepts this command at the management plane. It acts as an absolute barrier, blocking the action regardless of the user's role. It serves as an essential safety net for your critical infrastructure. Now let's do a deep dive into the types of locks available. Azure provides two distinct types of resource locks: cannot delete and read-only. The cannot delete lock, often called a delete lock, is highly flexible. It allows your administrators to read and modify the resource as they normally would, but it strictly prevents the resource from being deleted. On the other hand, the read-only lock is much more restrictive. It allows authorized users to view the resource, but absolutely prevents any modifications or deletions. Applying a read-only lock is essentially equivalent to temporarily restricting all authorized users to the reader role for that specific resource. This flowchart compares the two lock types side by side. On the top path, the cannot delete lock branches out to show that viewing and modifying operations are allowed, while deletion is strictly blocked. On the bottom path, the read-only lock is shown to be far more restrictive, allowing only viewing operations while blocking both modifications and deletions. Choosing between these two depends entirely on how much operational flexibility you need versus how strictly you need to preserve the resource's current state. Why and when should we use resource locks? The primary reason is to protect your mission-critical resources from accidental deletion or unwanted changes. This can happen due to human error, but it frequently happens due to misconfigured automated deployment scripts. From a governance perspective, locks are a post-deployment security practice. You should apply them after your infrastructure has been successfully deployed and stabilized. As a best practice, Microsoft highly recommends applying delete locks directly at the resource group level. This ensures that an entire grouping of production resources cannot be wiped out by a single mistaken command. This diagram illustrates where resource locks fit into your overall Azure governance strategy. Governance is multi-layered. You have Azure policies handling pre-deployment compliance and RBAC managing who has access. Resource locks sit on the right side as a crucial post-deployment control. Once your critical VMs and production databases are running, the lock is applied to freeze their state or prevent their deletion, acting as the final line of defense against infrastructure loss. Understanding scope and inheritance is vital for managing locks effectively. Resource locks can be applied at the subscription level, the resource group level, or down to the individual resource level. The most important concept here is the law of inheritance. When you apply a lock to a parent scope, all child resources within that scope automatically inherit that lock. For example, if you place a delete lock on a resource group, every single virtual machine, storage account, and network interface inside that group inherits the lock. Furthermore, if multiple locks are applied across different levels, Azure will enforce the most restrictive lock in the chain. This hierarchical tree demonstrates lock inheritance. If we apply a lock at the resource group scope, highlighted in red, you can see the arrows flowing downward to the individual resources like the virtual machine and the storage account. They automatically inherit the protection. If someone attempts to delete the virtual machine, the inherited resource group lock will block the action. This top-down inheritance makes it incredibly efficient to protect large environments without tagging every single item manually. Because resource locks can completely halt administrative actions, Azure requires highly specific permissions to create or delete them. Not just any administrator can manage locks. To add or remove a lock, your account must be assigned either the owner or the user access administrator built-in role. If your organization utilizes custom RBAC roles for granular security, you must explicitly include the Microsoft Authorization/locks/action permission in the custom role definition. Because locks are so powerful, it is a crucial design consideration to strictly limit how many users hold these specific permissions, ensuring your protection strategy cannot be easily bypassed. This diagram maps out the authorization paths required to manage locks. From the action of managing a lock, we check the required role. The paths split into the allowed built-in roles, owner and user access administrator. The bottom path shows the custom role requirement, specifically pointing to the exact action string needed in the JSON definition. If a user's role does not map to one of these three paths, their attempt to apply or remove a lock will be denied by the Azure platform. Applying resource locks can be done through various tools to suit your operational preferences. In the Azure portal, you simply navigate to the settings of your resource or resource group, select Locks, and click Add. For those who prefer automation, Azure PowerShell offers the new AZ Resource Lock Complete, where you can programmatically define the lock level and target resource group. Alternatively, the Azure CLI provides the AZ Lock Create command. For infrastructure as code enthusiasts, locks can be natively declared in ARM templates or Bicep files by defining a resource of type Microsoft Authorization/locks. This ensures resources are locked the moment they are provisioned. Here we see the multimodal deployment options for resource locks. Starting from the top, you can choose the manual GUI approach via the Azure portal. Moving down, we have the scripting options with PowerShell and Azure CLI, excellent for quick administrative tasks. Finally, at the bottom, we have the declarative approach using ARM or Bicep templates, which embeds the lock creation directly into your deployment code, representing true infrastructure as code maturity. Let's dive deep into a common gotcha with read-only locks. When creating locks, you must exercise caution because they can cause unexpected results. Resource locks get applied strictly to the management plane of Azure, meaning they restrict interactions with Azure resources, but not the internal data functionality. A classic example is applying a read-only lock to a storage account. While it seems harmless, it actually prevents users from reading the storage access keys. Why? Because fetching those keys is logged as a write operation on the Azure management plane. Attempting this will result in a scope-locked error. This visual explains the read-only gotcha perfectly. The user attempts what they think is a read action, listing access keys. However, the Azure architecture translates this into a management plane write action. The read-only lock evaluates this request, identifies it as a write operation, and immediately blocks it, throwing the scope-locked error shown in red. Understanding this distinction between management plane and data plane actions is critical for troubleshooting. Finally, let's discuss troubleshooting and removal. If you encounter a scope-locked error during routine maintenance, a lock is likely the culprit. For instance, if a delete lock is applied to a resource group, the operation to delete that group will fail because it cannot delete the underlying locked resources. To successfully modify or delete the resource, you must explicitly remove the lock first. This has a major impact on automation. CI/CD pipelines will fail if they try to tear down a locked environment. The best practice for automated updates is to script the removal of the lock, run your deployment, and immediately reapply the lock. This final workflow shows the best practice for dealing with locks in an automated environment. When a pipeline runs, it should first check if a lock exists. If it does, the pipeline temporarily removes the lock, proceeds to execute the required updates or deletions, and then safely reapplies the lock at the end. This ensures your infrastructure remains protected without hindering your operational agility.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this and all the the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now, the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.